Now that we have our class width for our frequency distribution table work that we're going to do in making our 5 classes, we want to make sure that we get the lower number and the upper number for each of our 5 classes in order to set up and find our frequencies. Now, with setting up the lower class limit and the upper class limit, we want the data to be the same accuracy as the data set that you have. And there's a couple different ways that you can start your process. We are going to start by having our lower class limit of our first class being the smallest number within the data set. So remember, we had this data set, and in the first segment, we looked at how to find the class width. The smallest number within all of these data values is 15. So we're going to start our lower class limit of our first class with 15. And then because we want a class width of our 7, our best way to kind of do this is to think of, we want the spans of values for each of the classes. So we're going to have 5 different lines here since we want 5 classes. And what we're going to do is take for each lower class limit, get the next lower class limit by adding our class width, in this example 7, to each of the previous class widths. So our first lower class limit is 15, our smallest data value. And when we take our 15 and add our class width of 7, we will get 15 plus 7 is our 22. When we take our 22 and add our class width of 7, we get 29. When we take 29 and add our class width of 7, we will get 36. And we take the 36 and add our class width of 7, we will have 43. And notice there are now 1, 2, 3, 4, 5 of our classes that we've just found the lower class limit for each class so far. Now each of these classes are spans of numbers that we want to see where our data values fit in, and then we'll do a tally for our frequency. We still need to also do the upper limit for each class. Now the upper limit for the first class is going to be a value that's right before the next class to the same accuracy that you have with the data set. Our data set is to the nearest 1. So the nearest whole number right before 22 is 21. So this first class will have a lower class limit of 15 and an upper class limit of 21. The number right before, the whole number right before 22. Now the third class is going to start at 29, so the second class had to end at 28. The third class begins at 36, the fourth class begins at 36, so the third class had to end at 35. The fifth class begins at 43, so the fourth class had to end at 42. And when we're looking at finding the upper class limit of the fifth class for this example, our upper class values, our upper class limits are also the same class width away. So if you'll notice, 21 plus 7 is our 28, 28 plus 7 is our 35, 35 plus 7 is going to give you 42, and 42 plus 7 is 49. So these are our spans of numbers for each of our class. We have our first class spans from 15 to 21, the second class from 22 to 28, third class from 29 to 35, the fourth class from 36 to 42, and then the last class from 43 to 49. The next thing we're going to do is take and just do a tally for now, and then we'll change it to the numerical representation. So we're going to tally for each of these data values which class they fall in, and we'll systematically go through this. So for example, the data value 32, that falls in the third class's span of numbers. 32 is a number somewhere between 29 and 35. So I'll put a frequency tally of 1 there. The next number, 15, that's in the span of numbers from 15 to 21. So I'll put a frequency tally there. And so we do this for each of the data values. 27 is in the second class. Our 18 is in the first class. 16 is also in the first class. 24 is in the second class. 36 is in the fourth class. 21 is in the first class. 42 is in the fourth class. 32 is in the third class. 46 is in our last class. 15 we have in our first class. 17 is also in the first class. 38 is in the fourth class. 42 is here. 15, again here. 24 is in the second class. And then finally 37 is in the fourth class. So we're going to take these tallies and we're going to turn them into their numerical representation. My first class I have 5, 6, 7. So I'll just go ahead and replace that with 7. The second class I have 3 tally marks. So I'll write 3. In the third class I have 2. In the fourth class there are 5. And then I had 1 data value that fell in that last class. Just kind of a quick double check. If we add up the data values we have here, so we have 7 plus 3 is 10, plus 2 is 12, plus 5 gives me 17, plus 1 is 18, and I had 1, 2, 3, 4, 5, 6, 3 rows of 6, which is 18 data values. So that helps us do a double check. Now, sometimes the limits are actually, instead of doing the lower class limit and the upper class limit as the lower data values and the upper data values that they represent, they actually will give you not only where the data values could be in the spans, but actually where the classes would kind of meet halfway in between. And those values are called the class boundaries. And I'll have a lower class boundary and an upper class boundary for each class. So we'll write on this far end lower class boundary. And on the other side of the upper class limit, we'll write upper class boundary. It's just another way to denote your classes. Okay, the boundaries are where they meet. So look at where this first class ends at 21 and the second class starts at 22. Those bars, if you graph them on graph, would not touch. And we want to have this information where we might be able to use it for our histogram. So we want to have where the bars would touch. So we're going to share the distance between 21 and 22, which would mean that we would end this first class at 21.5 and as an upper class boundary, and start the second class's lower class boundary at also that 21.5. So we're meeting halfway for that point of our lower class boundary and our upper class boundary. So for the second class, it'll go up to 28.5, and 28.5 is the lower class boundary of the third class. 35.5 is the upper class boundary of the third class. And so that would give us 35.5 as the lower class boundary of the fourth class. And then for the fourth class's upper class boundary, we'll have 42.5, and that's the lower class boundary of the fifth class. And then the last thing we need to do is make sure that the spans are all equally widthed. So we would need to go down a half on our first entry of our first class. So this will have a lower class boundary of 14.5. And the last class will have an upper class boundary of 49.5. So another way to denote your classes. The last thing I want to do for this segment is to also get some information that we would need if we are looking at trying to use the information off the frequency distribution table to graph a frequency polygon. And with the frequency polygons, we want to find what the midpoints are of each class. And the midpoints we just take and add the two class limits, the lower class limit and the upper class limit, and divide by 2. 15 plus 21 is 36, and 36 divided by 2 is 18. You could also have added the class boundaries of the class and divided by 2, and you would get that same number, 18. Now we can do that for each class. However, your class midpoints are also going to be the class width apart. So once you have your first class midpoint, you can find the rest of them by just adding the class width to it to get the rest of them. So 18 plus 7 is 25. 25 plus 7 is 32. 32 plus 7 is 39. And 39 plus 7 is 46. Notice that with each of these, if I were to do the other way of the average, 22 plus 28 is 50, and 50 divided by 2 is 25. I would still get the same answer. 29 plus 35 is going to give me 64, and 64 divided by 2 gives me my 32, etc. through all of that. So here we have ways of getting the information for our frequency distribution table. This is a frequency distribution table, and working with the frequency distribution table so that we have all the information we need to pull it off and draw histograms and frequency polygons.